Hello students, today we'll discuss about Boolean logic. In today's session, we'll have elaboration of Boolean logic and logic gates. Let's start with logic gates. Logic gates perform basic logical functions, and these are the fundamental building blocks of digital integrated circuit. Logic gates are primarily implemented using diodes or transistors acting as electronic switches. Now, some circuits may also have very few logic gates, while other microprocessors may have a lot of millions of them. It could be over there. The next thing that we must get familiar with is a truth table. This is also one of the very important uh, topic in Boolean logic. It is a table which represents all the possible values of logical variables. Now, table we can see over here, collection of tables are available over here, which has got a collection of logic variables with all the possible results. A truth table with n input variable will have 2 to the power n input. That is, if n means the number of variable is 3, then its possible input combination would be 8. So for example, if there is one variable means n is equal to 1, then its possible input combination would be 2 to the power 1, that is 2 input combination. Okay, next, well, we are having is not gate. Okay, so gates are something which could be defined as an electronic circuit which takes input and in return will return you some output, will give you some output. So the first gate that we are having over here is not gate. It will take only one input signal and will produce only one output signal as well. In the list of gates, this is the first gate, that is not gate, and out of all the gates, this is the only gate that accepts only one input signal and as exceptional to the other gates. Okay, we can just see input signal is being provided, and in return the output that we are getting is the negation of the particular element. Like if input we are having is 0, then the output that we'll get would be the negation of a, that is 1, and vice versa. Next gate that we are having is OR gate. It will all take two or more input signal, will produce only one output signal, similar to the NOT gate. If any one of the inputs are 1, then the output would be 1 only. OR gate we can understand with the diagram of a like circuit. We need to draw two variable uh, circuit diagram. This one is along with the two variable truth table. As we can see over here, in any of the inputs is 1, the output that we are getting over here is 1 only. We'll also try to understand OR gate with the help of truth table, three variable truth table that we are having over here. As we can see, any of the input, any of the column is having 1 as input, the output we are getting 1. Okay, next gate is AND gate. Similar to the OR gate, it will take two or more input signals and will return only one output signal. If all the inputs are 1, then the output in case of AND gate will be 1 only. Okay, as we can see over here, this is a ice cream shaped circuit. As it takes two input, different circuits are here, 3 inputs and 4 inputs, but in return it will only give you one output. And the truth table for AND gate, here we are having, for the possibility of AND gate is that all the inputs have to be 1, then only we'll get the output as 1. As we can see in the last case, all the input is 1 over here, and that is why we are getting 1 as the output also. Another thing we need to keep in mind over in case of AND gate is the uses of AND operator. we must understand while using AND gate, the AND operator is used, and that is represented by the dot symbol. Next one is NOR gate. In simple words, we can say not or. And the first 2 points will be similar. It will take two or more input signal, will produce only one output signal, but actually its behavior would be what? If all the inputs are 0, then the output would be 1. Just as we have discussed, it would be not or. Okay, we can see the circuit also. It's or along with a circle over here which represents that is not or. Okay, for in order to get the output as 1, all the input should be 0, that is it should be false. Next one is NAND gate, which could be understood as not and. The first 2 points once again would be similar to the other gates. The last point we come to, if all the inputs are 1, then the output over here would be 0, which is just the opposite case of AND. If we are having all the inputs, if we are studying about AND case, so in case of all the inputs are 1, then only we get the output as 1, but here it is just the opposite case. When all the inputs are 1, we are getting the output over here as 0. So the same thing is written over here. If all the inputs are 1, then the output would be 0. The same case is with two variable as well. Okay, wherever we are getting two ones in the input form, there we are getting output as 0. Next we are having XOR gate. It is also known as exclusive OR gate. It will also take two or more input signal, will produce one output signal. The output produced over here would be 1 when if it has got the input combination as odd number of ones. We can just see very clearly with the help of truth table. Wherever we are having odd number of ones, the output it is resulting it into the 1. Okay, wherever we are having even number of ones, it is the output is turning up as 0. Okay, XNOR, it will be also accepting two input signal, and return will give one output signal. It is called as inverted XOR. As you can see the circuit diagram of XNOR over here, it has got the diagram of OR along with AND that represents not OR, and here we have got a symbol that is associated with XNOR that makes it different in comparison to the other circuit diagram. The output produced over here would be 1 if all the input combination is 0. Okay, it would just be the reverse of XOR, as we have seen in case of XOR. So whatever is the case of XOR, here the case would be just reverse. If the input combination have even number of ones, but even number of ones you are having, that means the output would be 0. And if all the input combination is 0, which is the reverse case of XOR, you can just have a look at the previous slide over here. Okay, if all the input combination is 0, so it used to produce 0, but since we are studying about XNOR, that is the exclusive OR, that means it should have to be the reverse of XOR. So that is why here we are representing with the reverse, the inverted relation. Okay, and here we comes to the points to remember. Here all the points are given in respect to two variables with respect to A and B. The most important point at the end is given in the form of note. NOR and NAND gates, these are known as universal gates. Why? Because it could be used to implement any digital circuit. It could be used in place of any digital circuit, as the cost behind it is also very low, and it becomes cheaper also while infusing these gates into our circuit, and overall cost is just reduced. So thank you all of you.